This video is all about periodic functions and trigonometric functions. So before we get to trig functions, we need to learn what a periodic function is. And a periodic function is a function that has a pattern in its y values that repeat at regular intervals. So all that means is that there is a pattern that just repeats over and over again on the graph. So if we look at these first three examples, these are all examples of periodic functions. So this first one, it looks like a wave, and this wave shape repeats over and over again. If you look at the next one, this kind of dome shape repeats over and over again. And if you look at the third one, this wave repeats over and over again. You just don't really see it. So if you have this interval that just repeats over and over again, it is a periodic function. Now, if you look at the next three functions, these are not periodic. And you may look at the first one and say, well, I just see these little triangles over and over again, but they're not identical. This triangle is one height, this triangle is another, which means that the y values aren't the same throughout. Same thing with the next one. You have this little dome shape, but it gets higher and higher each time, so it is not periodic. And same with the last one. You see these steps, but they don't have the same y value. So those are not periodic functions. Now, if something is periodic, there's some terminology that we need to learn. And the first is when you have one complete pattern in your periodic function, that is called a cycle. And the length of one cycle, so the horizontal distance of a cycle, is called the period. And the period will be very important when we're determining equations of periodic functions. Now, the next one is the central axis, or the midline of a periodic function. And it is a horizontal line that is exactly halfway between the max and min value. And we can calculate that midline or that central axis value by taking the average of the max and min, because that's how we get halfway. So we take our maximum value, we take our minimum value, we add them up and divide by 2, and that will give us the equation of our midline. And because it is a line and it's a horizontal line, the equation would be y equals a number. So if we just look at this little example, let's say I have something like this, okay? My central axis or my midline is right here because that is my halfway point. And if I had some max and min values, let's say we have 4 here and -4 here, if I add those numbers, I get 0, and when I divide by 2, I also get 0. So the equation of the midline is y equals 0. Now the next definition or key term that we have is the amplitude. And the amplitude is half the distance between the max and min value. Or you can also think of it as the distance from the midline to either the max or min. So if again we look at the little example I have, this here would be my amplitude from the midline up to the maximum. Or I could say it's from the midline to my minimum. And because I know my midline is at 0 and my maximum is at 4, my amplitude is 4 in this scenario. And if my numbers aren't so nice, I can calculate the amplitude by subtracting my max and min, and that will give me the distance from the max and min, and then cut it in half. So max minus min divided by 2. And what's nice, or what's good to know about the amplitude, is that the amplitude is always going to be positive because it is a distance, and we can't have a negative distance. So let's take these definitions, these key terms, and apply them to a few periodic functions. So here we go. In our first example, we know it's periodic because we have this shape here repeating over and over again. So first thing, let's state the period, the length of one cycle. So the period here, I can take a repeating interval from anywhere on this graph. I could have taken this one if I wanted to find my period. But I am going to take this initial one that I highlighted because it will be easier for me to measure my period. My cycle started at 0 and it ended at 1, so the period is 1. My max and min values. My maximum is 2 and my minimum is 0. Here's the max value, here's the min value, the highest and lowest points on our function. So our midline is exactly halfway between 0 and 2, and that we can see is going to be at 1. So for my midline, or my central axis, it is y equals 1. You could have also taken your max and min, so 0 and 2, add them up, 0 plus 2, and divide by 2, and you'll still get 1. And then finally our amplitude, it is the distance from the midline to the max or min. So visually, this right here would be my amplitude, or this right here. So I can clearly see that my amplitude is also 1. But I could have also used that little equation, which is the max, 2, minus the min, 0, divided by 2, and you get 1 in that way as well. All right, let's try the next one. So here again, we have a periodic function. You can say the function starts anywhere or the interval starts anywhere, but I'm gonna say that this here is 1 cycle, and then it cuts and pastes over and over again. So looking at this, my period, I'm just gonna label it P for period, is 2 units because we're going from 0 to 2. You could have also looked at a cycle as starting from max to max, so from 2 to 4, and you can see that the period is still 2. Now my maximum value is 1, and the minimum value is -1, and we are talking about the overall max and min. So then my midline, or my central axis, is at y equals 0. Again, you can see it visually halfway between 1 and -1 is going to be the actual x-axis. You could have also used the max plus min divided by 2. And then my amplitude, so the distance from the midline, which is 0 to a max or min, is 1 once more. Now I want you to pause the video and try these last 2 examples on your own, and then check back with the video to make sure you've done it correctly. All right, so if we look at this third example, I highlighted this as a cycle, but you could have started right from the y-axis and so that this was a cycle here, just this kind of inverted V shape. But regardless of what you highlighted as 1 cycle, your period should be 4. Then our maximum is between 3 and 4, so we estimate as 3.5, and our minimum is 1. And because I did have a decimal for my maximum, I did use my midline and my amplitude formulas. So for the midline, because it's halfway, it's not something you have to memorize, but because we need to be halfway between max and min, that should make you think of taking the average, which means add your max and min and divide by 2, so we get 2.25. And then for the amplitude, we're going to subtract, so 3.5 minus 1 divided by 2 to get 1.25. All right, for the next one, it's a little bit more funkier, so I just started with the beginning at y equals, or on my y-axis, and then I followed the shape until I saw it repeat. And you might say, oh, right here, but I see that at the beginning, you start horizontal and you work up. Here, that did not happen, so I continued, and then it stopped right here because then we see the shape repeating. You could have also said, you know what, I'm just going to use my 2 maximums, so from here to here, and that's 1 cycle, and that'd be perfectly fine, as long as you get a period of 8 units. Then our maximum is at 5, and our minimum is at 1. So then our midline is at 3, because that's halfway between 1 and 5, and then our amplitude is 2. And you could have used the formula here, or you could have seen that if your midline is at 3, from 3 to 5, that's 2 units, or from 3 to 1, it's 2 units as well. Now that we know our terminology, there are 3 periodic functions that are related to trigonometry, and that is the sine graph, the cosine graph, and the tangent graph. So that's what we will be looking at now. So I want you to pause this video and I want you to fill in the table of values and draw the graph. So in your table of values, you're going to use your calculator and sub each of these points in for your angles, and you're going to write it in for x. So take sine 0, sine 30, sine 60, and you'll just write the answer in this box below with 1 decimal. please make sure that your calculator is in degree mode. And once you've done that, you can go ahead and graph. And I have made a note here about the scale. I want one box horizontally to be 15 degrees. So every 2 boxes will be 30. So 30s here, 60s here, 90s here, etc. And then on the vertical scale, 10 of these squares is 1 unit. So 1 unit will be all the way at the very top and -1 at the very bottom. So please pause the video here, complete the table and the graph, and then come back to the video to check your work. All right, so hopefully you got the following for your table, and hopefully your sine function looks like this. And it is periodic because this will continue forever in both the positive direction and the negative direction. And the reason is, if you notice, we're going from 0 to 360, which is a full rotation of a circle. So if I continue past 360, that just means I'm doing my second rotation or my third rotation. Now, when you actually start graphing sine, I'm not going to need these middle points here. The points that I really care about, I'm going to highlight. And that is the point that is on the midline at 0, then the one at the maximum at 90, back on the midline, the minimum, and then the midline. Those are the ones that we're going to care about. The other ones, they help us create the shape and the nice curved sinusoidal function, but that's it. So let's go ahead and jot down some properties. So the first one is about those key points. So let's just write down the coordinate. We had 0, 0, 91, 180, 0, 270, -1, and 360, 0. The amplitude is 1 because that's the distance from the midline, which is at 0, to the max or min. The period is a full rotation, which is 360 degrees. The maximum value is 1 when x equals 90 degrees. And the minimum value is -1 when x equals 270 degrees. And we can see that on our graph. Now the domain, because we can rotate as many times as we want, and we know this pattern will continue in both directions, the domain is x is an element of all real numbers, no restrictions. And the range, we do have restrictions because we have that max or min value. So y has to be greater than or equal to -1 or less than or equal to +1. And then in terms of increasing and decreasing, we want to read our function like a book from left to right. And if I do that, I can see from 0 to 90, my function is increasing. And then from 90 to 270, it is going down. And then from 270 to 360, it goes back up again. So I will jot that down. Increasing from 0 to 90, and then 270 to 360, and then 90 to 270 degrees, it is decreasing. And now that is our sine function. And I don't want you to remember those 5 key points. All you really have to do is remember that sine starts at the midline. And then from there, it goes upwards and follows that wave. So I drew it super quick. And those key points occur every 90 degrees. And the reason they occur every 90 degrees is because of the quadrants. This is the positive x-axis, that's 0, 90, 180, 270, and a full rotation is 360. So that is why those are our key points. So if I have to go label things, there we go. I just drew my sine function really quickly. I didn't care about those middle points, just the max mins and the midlines. Now, let's repeat the process, but this time for our cosine function. So I want you to pause the video, fill in the table, do your graph using the same scale, and then come back to check your work. All right, so here is our cosine function. So here are the coordinates that we have, and notice they are similar to the sine ones, but it's like our sine function has been shifted. Instead of starting at the midline, we're starting at the maximum and going down. And just like with the sine one, I'm gonna highlight the key points that we actually care about for when we're graphing. And that's gonna be our maximum value, which is at 0, the midline value, the minimum value, that's at 180, the midline, and the maximum. So let's go ahead and write down those key properties and those key points. So we have 0, 1, 90, 0, 180, -1, 270, 0, and 360, 1. Notice our key points are still occurring every 90 degrees. Our amplitude is still 1. Our period is still 360 degrees. The maximum of 1 occurs when x equals 0 and 360 degrees. And the minimum of -1 occurs when x equals 180 degrees. Our domain and range are the same as our sine function because it's the exact same shape, just shifted. So y is greater than or equal to -1, less than or equal to 1. Now our increasing and decreasing is slightly different because of the different starting points. So we start off decreasing from 0 to 180, but then from 180 to 360, we are increasing. So increasing from 180 to 360 and decreasing from 0 to 180. And again, the cosine is very quick to graph as long as you remember you're starting at your maximum of 1 and then following the shape. And every key point occurs every 90 degrees. Now our final trig function is the tan x function. And this one's going to be very different from sine and cos. So again, I want you to pause the video and fill in your table. There are more coordinates there that you need to plug in. And I also want you to take note that our scale is different here. The horizontal is still every 15 degrees, but for our y-axis, 1 square will be 1 unit. So pause the video and try it out. All right, so hopefully for our table of values, we have something like this. And you might have noticed that 90 and 270, you got an error on your calculator. And the reason is we have asymptotes on our graph. And asymptotes are just lines that your function approaches but never passes through. But you also know that this is the case and that you should get an error if we think about our special triangles. So I'm going to quickly draw in that imaginary triangle that we had that was really kind of a sliver. So we had 90 here and 0 here, 1, 1, 0. And if I'm using 90 as my reference angle, opposite is 1 and adjacent is 0. And I know 1 divided by 0 is undefined. So that's where we're getting that error message in our calculator and why we have those special asymptotes on our graph. So if we look at our graph, it looks very different from sine and cosine, but it is periodic because this wave motion here repeats over and over again. And we know that it has to repeat because it is based on your unit circle and that idea of the rotation around 360. So is the graph of y equals tan x periodic? Yes, it is. There is no maximum value. Our maximum value is infinity and our minimum is -infinity because it will go on forever. And now, because we don't have a maximum value, then we can do our range quickly and say that it is y is an element of all real numbers. Now, I do want to make a note about asymptotes before we do our domain. So we have here at 90 and 270 asymptotes. But we know that those asymptotes, we're going to have them throughout our entire function from -infinity to infinity. So right now we know that it's at 90 and 270. And if we look at the pattern, we're just adding 180 degrees each time, which should make us think of an arithmetic sequence. Now, we can think of the equation of asymptotes if we want the general one. You're taking 90 and you're adding on 180 degrees n times. So n can be 1, 2, 3, 4 times, whatever you want. But we can't have it be a decimal. So we have to state that n is an integer. Now this is going to be important for our domain because if you look at our x values, x can be anything except for those asymptotes. And there's our general equation for the asymptotes. So the domain is going to be x is an element of all real numbers such that x cannot equal what we just wrote, 90 plus 180n, where n is an integer. Now don't worry, because n can be an integer, it can be a negative number as well, which means we can go into the negatives for our asymptotes. And there it is, that's your tan function. Now we're not going to do any transformations with tan, but it is good to know what this trig function looks like. We are mainly going to focus with sine and cos, so those are the ones that you really want to know how to draw really quickly and accurately. But you still need to know these asymptotes and properties for tan as well.